on day one, and that's isosceles. You guys remember from day one, isosceles triangle, two sides equal, right? Two sides equal. There's a lot more than that, and you're going to learn that today. Not only are two sides equal, but two angles are equal in an isosceles triangle, right? Two sides and two angles. Biggest thing I need for you guys today, where are those angles? Where can I find those angles? And the answer is, well, it depends on where the sides are. Look at my second diagram down here. I'm telling you AB congruent to AC. So we all agree that's isosceles because it has two sides equal. So now where are the angles that are equal located? Across, opposite, across from the congruent sides. So I have AB and AC equal. I look across from them and I see angle B and I see angle C. Those are your two congruent angles in an isosceles triangle. They are opposite the sides. Do not get in the habit of just assuming it's the bottom two either. If I take my triangle here, take a look, X, Y, Z, and I mark these two sides congruent. Is that triangle still isosceles? Yes. So in this case, where would my two congruent angles be here now? One's here. Not here. Don't do it. Oh, there we go. All right, Haley, where are my two congruent angles in this triangle? Yep, X and Y. Good. All right, so please don't assume it's the bottom two. All right, it is always across from the sides. Now, in return, we can go in reverse. Everyone agrees those angles are congruent, makes it isosceles. Now, using the angles, you can find the sides. It works both ways. So in my diagram down here at the bottom, if I tell you angle B is congruent to angle C, now we could also say, oh, now the sides are AB congruent to AC. So it works both ways. If I know the angles, I can find you the sides. If I know the sides, I can find you the angles. Before I move on, though, let's just make sure we are solid with this. What I just showed you, the congruent angles across from the congruent sides, only works in a single triangle. What do I mean by that? Take a look here. If I have triangle ABC and DEF, and let's just say I mark AB congruent to DE, that does not mean that angles C and F are congruent to each other. It only works if the congruent sides or angles are in the same triangle. Everyone good there? It only works in a one triangle only. All right. Before we do some actual applications here, I don't want to say congruent sides or congruent angles. They have actual vocabulary terms associated with them. So first, how about the angle between the congruent sides? The angle between the congruent sides. So what angle am I talking about in my diagram then? What's the angle in between the congruent sides up here? The seventh spot, where am I looking here? Amy, what angle am I talking about here? The angle in between, angle A. All right, so everyone, I'm talking about angle A. And think of it as this too. It's the non-congruent angle. It's kind of like the outcast angle. Maybe some of you guys can relate. No? Okay, never mind. Got that, Zoe? Good. Thick skin in here, thick skin. The non-congruent angle. It's referred to as the vertex angle. The congruent sides. Let's stop saying that now. The congruent sides. The two sides that are congruent in an isosceles triangle. Anybody know the name? So drop some knowledge. All of us have two of them, and we walk with them. Matt?
Legs.
Nice job, Matt. There you go. I knew you belonged in honors. Yep. Legs. Good. How about the unequal side? The outcast of the sides. The unequal side. And I am not a big fan of this at all. It's called the base. Why am I not a big fan of that term? Because everyone's in the middle school mentality and always thinks base equals bottom. No, not anymore. The base is just the unequal side. I don't care where it is. And then how about the two congruent angles? So in this case, B and C. What are the two congruent angles called? Well, here's a hint. What's the side in between them called? What did we just call the side in between the, so in this case, BC. What's BC called in this triangle? That's the base. So the angles surrounding them are called the base angles. But again, not necessarily found on the bottom. Yeah. So just some vocab so we can start talking to each other. All right, now let's start applying this now. Woo! All right, there's my diagram. A lot of markings on there of arc marks and hash marks. I'm looking for an angle that's congruent to R, and I'd like an angle that's not already marked. All right, so please don't respond with angle S or angle SVW. So take a look. Angle R is part of an isosceles triangle. Use the facts that the congruent angles are across from congruent sides. So here we go. Start us off. Angle R is going to be congruent to 1, 3 here. Ksenia, welcome back. Angle R and angle, whoa, you say V. I'm going to ask you which one of the three you're talking about.
Angle UVR.
There you go. I like that a lot better. Angle UVR. Where do we get that from? Real quick, where do we get that from? Take a look. I'm talking about isosceles triangle URV. Notice the two sides are congruent. So the angles opposite them would be congruent, R and UVR. Why? This is what we're going to put in our reasons column tomorrow when we start isosceles triangle proofs. I know you're excited. You probably won't be able to sleep tonight. Why? In a triangle. That phrase needs to be there, and I'll tell you why when we're done writing. In a triangle, congruent angles are across from, and maybe some of you guys could finish this. In a triangle, congruent angles are across from, how am I going to end it? Where are they across from? Congruent sides, yep. It will not bother me. It will not bother me if those two are switched when you write it. It won't. It's the same thing. All right, it won't bother me. What will bother me is if this phrase is not at the beginning. And here's why it will bother me. If you just write congruent angles are across from congruent sides, that's a false statement. Because if here you go. Whoops, sorry. That's not true for a pentagon. If I put up a parallelogram, it's not true. It's only true in a triangle. So that's why that is a must. You have to start out within a triangle. All right, how about side RT? RT is congruent to, make sure you stay in the same triangle. Stay in the same triangle. Don't bounce around the triangles. RT and, what else you got? One, Charlie? TS, good. TS. Again, I want to make sure you guys realize Charlie's using the big one now. Why is the big one isosceles? What does it have in it, Zeev? Two congruent angles, R and S. So again, watch. You have to stay in this triangle. Look across. And that's where you guys get the sides. And same reason, if you guys want to switch congruent angles with congruent sides, go crazy. Just want to make sure we have this down pat for tomorrow. All right, one more. VW. VW. One more isosceles triangle in that diagram we haven't talked about. VW and what other side are going to be congruent here? Josh?
WS.
WS, yep. And we're using this isosceles triangle there. All good? Now let's just apply some numbers to it before we end. Today's a quick day. Should be no reason why all of you don't leave the room today with the assignment already completed. All right, first example. Everyone see two isosceles triangles. One on the bottom, one on top. All right, so let's start on the bottom one because I'm given 55 degrees there. Anything else you know about that triangle you want to tell me about? I know it's isosceles, but what else here? What else? We talked about a bunch today now. I know these sides are congruent, so anything else you want to tell me there? 1-5, Gabby, anything? There are vertical, yep, so they're going to be congruent once I find x, though. I'm going to try to get x. So if that's 55, anything else you know? Yeah, the other one's 55 because, look, across from the congruent sides are congruent angles. All right, let's keep going now. Gabby hooked you up with the 55. Now I think that's enough information for all of us to find x now. How would you find x? I don't know. I don't want to know what it is. Just what's your process of getting to it. Zoe, go ahead. How are you getting to x?
55 plus x equals 180.
There you go. I want to hear that 180. So 180 minus those two 55s will get me there. And you could set up the equation just like you did and solve for x. And when somebody has it, go ahead. Let me know. When you have it, though, take your time. Josh, when you have x, let me know. 70. Good work. 70 degrees for angle x. All right. I don't know if anybody was paying attention. Gabby gave it away a little bit, but that's fine. I have no angles in the top isosceles triangle. But how can you find an angle in there? Get me an angle inside the top isosceles triangle now. Where's it going to come from? Josh, again on fire.
Vertical angle.
Yep, these two are vertical, so if one's 70, the other's 70. And a reminder that that triangle's isosceles, so how would you go about finding angle y now? If you know it's isosceles. Let's do this. One's, owes me a couple here. Go ahead, Ian. Get me to angle y.
You take 70 minus 180, or 180 minus 70.
Yep, that'll give me what's left over for both angles. And what do you know about the two angles that are left over? Yep, because they're across from the congruent sides. So divide that by 2. Everyone's good? And then how about angle y now? 1-5, Gabby, when you're ready. Because it is 55 degrees. Good work. A little bonus, honors kids. What can I say about these lines then? I know they're not congruent, but I just found out that that was 55.
But they're parallel.
They're parallel. There you go, Aaron, because these are what?
Alternate interior.
Alternate interior. All right, good deal. Diagrams, not drawn to scale, right? All good? Are these triangles congruent? Oh, silence.
No.
How many methods do you have? How many methods do you have? 5. We can get rid of HLY. It's not a right triangle. What about, is any of the other 4 methods work here? Is angle away? Never. All right, don't, oh, look, all 3 angles are equal. Doesn't matter. These why is this not side angle side either? This side is not congruent to the other one, right? Everyone see these triangles not congruent. All right, angle's not away, and this is not side angle side because the 2 congruent sides are on the same triangle. All good? Good discussion there. All right, here you go. Next one. I got another isosceles triangle. First question I have for somebody. Describe to me where the congruent angles are then. They better be in the same triangle as the congruent sides. Okay? Just describe to me. Actually, don't put it on your paper. I'll just put it on mine to help you guys. Okay, now tell me where the congruent angles are with the letters. Where are my congruent angles? Whoa, going back to you, Gabby. B, all right, what's C you talking about, though? BCA, good. These are the 2 congruent angles. Remember, hey, if some of you are thinking, oh, I go here and here, you're using 2 different triangles. It's got to be in the same triangle, so that's why I'm going here and here. All right, good. Thank you, Gabby. Next up, how do I get to X? I know it's congruent to that one. Can you find the other one that it's congruent to here? This one right here, ACB for me. How can I find that angle? Oh, 5 spot. Haley, how can I find ACB for me? Because you knew they were what? Linear pairs, great use of your vocabulary. So that's 70. So that's got to tell me x is 70. And finally, how about y? How do I find angle y? Now, a couple different ways you could get there. Ooh, 1/3. Ksenia, start. End us off on the right note.
I did 90 plus 70.
Yep.
And then subtracted that from 180.
Yep. Basically, she's saying, hey, everybody take a look. I have a triangle here that totals 180 degrees, and I already know 2 angles out of 3. So y is 180 minus the 90 minus the 70. And how about angle y for me? One last question. It's your job here, so go ahead. Oh, boy. 20. Okay. Everyone look at the bottom of your page. Let's just make sure we're good here. What I expect. Be ready to factor. Now look, I know you can use this, but remember, this is just a check. I am still looking for, when I walk around tomorrow, this, your work. All right, your work for factoring. Just don't go right from the equation to the solver. It ain't gonna happen. All right, it's not gonna give you credit. Should be able to finish within plenty of time. All right, work whoever you need to work with. Call me over if you struggle with those factoring ones. I will help you.